Consider the system of linear equation 3 by 3, that is 3 equation with 3 variable. You can see here x1, x2 and x3 are the 3 variable with equation number 1, equation number 2 and equation number 3. Now the given system of linear equation can be written in the matrix form, and that matrix is called as a augmented matrix. So in solving the system of linear equation, our first step to write the given system of linear equation as a augmented matrix. It is very simple. Write the coefficient of variable first, say a11, a12, a13 and draw a dotted line or just a line and write down the constant to right of this line, say v1. Similarly, we can write the coefficient of second row. So a21, a22, a23 and this is v2. Similarly, a31, a32, a33 and this is v3. Writing the given matrix in this form is called as augmented matrix. This is called as augmented matrix. And this is the system of linear equation. Now, our job to use row operations to reduce this augmented matrix to the form 1, 0, 0, then some number, number, 0, number, draw the line. This one is also number, this one is also number, this one is number. Now if possible to reduce the given matrix in the form 1, number, this line, number, 0, 1, number, 0, 0, 1 and then number. Then we can say system has unique solution. So we'll get a unique solution. Consider the system of linear equation. Our aim to find the solution for this linear system. If we are able to convert this matrix in this form, then we solve for z and for x and y and x, and there is a 1 value of x, y and z, so it is a unique solution. So our first job to write down the given matrix or given linear of system in augmented matrix form. So this one is the 1, 3 minus 1, we draw a line, this is 15 constant, this is 2, this is 1, this is 1, this is 7, this is 1 minus 2, and this is 0. This one is our augmented matrix. Now using only row operation, we'll try to convert the given augmented matrix into this form. If it is possible, we'll get a unique solution. So if you remember, in the previous class or video, we discussed how to perform the row operation. So on 1 is already, so no need to change, we need to make this one as a 0. So using this one, we'll make this one 0, and that is we need to change R2. How? R2 minus 2 times R1. Now that first row will not change since we are changing second row, so we'll write third row only. After that for writing the element of second row, we need to perform this operation. So in a rough work, you can write 2 1 1, and then this multiplication minus 2 times R1. So 2 into minus 1 is minus 2, 2 into 3 into minus 2 is minus 6, minus 2 into minus 1 is 2. Now we always add. So this is 0, this is minus 5, this is 3. So we'll get second row as 0, minus 5 and 3. Next, we need to make this one as a 0. So we'll perform required matrix operation as transformation as we need to change R3. How? R3 minus R1. So the element which are not going to change will write first, that is the first row, and second row will write first. Now here we forget to write this element, so we need to perform that constant also. So this is 15, this is 7, and 15 into minus 2 is minus 30. So this total is minus 23, so we need to this minus 23. And the element which are not going to change will write first. So you can see 1, 3, minus 1, 15, 0, minus 5, 0, minus 5, 3, obviously that line, minus 23, and since we are changing R3, so we will not write the element of R3. This operation, so R3 is 1 minus 1 minus 2, and that constant is 0, and if you multiply means that is we perform this minus, so minus 1 minus 3 plus 1, and this is minus 15. If we add, so we'll get 0, minus 4, minus 1, and this is minus 15. So third row becomes 0, minus 4, minus 1, and minus 15. Next, We want to make this one as a 1. So one option, either you can divide by -5, or you can see that -4 and that -4 and -5 are the LCM, so we can manage that also, but we'll perform this one. That is, we'll first divide this, or second we perform that to make 0 such a way that R3 can be changed first multiplying R3 5 times and 4 times R2. So LCM 4 of 5 become 20, so that become 0. How? See. So we want to change R3, so we'll write 1, 3, minus 1, 50, that is first row. We'll write second row, 3, minus 20, and we are not going to write the third row. Third row element is 0. Third row element is 0, minus 20, minus 5, and minus 75. And minus time second row element is 0, 20, minus 12, and 92. If we add, we'll get this one is 0, this one is again 0, this one is minus 17, and this one is a 17. So we'll write 0, 0, minus 17, and this one is a 17. Now our job to make this minus 5 as a 1 and minus 17 as a 1. So we can multiply R2. So we need to change R2 by multiplying minus 1 by 5 times R2. And we need to make this one as a 1. So we need to change R3 by minus 1 by 17 of R3. That is, here we are doing two operations at the same time. So R1 not going to change, so we'll write as it is. R2 is going to change, so 0 by some number is 0, this is 1, this is 3 by minus 5, and this one is minus, so minus become plus, so 23 by 5. This is 0, 0, this is 1, this is again minus 1. So this is how we change. Now next, we have converted the given augmented matrix in the form where that unique solution can be found, that is 1, 1, and 1. Below the diagonal this is 0, and above the diagonal are non-zeros. It may be 0, but numbers, so that is not our concern. From this you can write three equations as it is: 1 into x, so x plus 3 times y minus z is equal to 15. This is, you can say, number 1. From second row you can write the second equation. So y minus 3 by 5 z is equal to 23 by 5. Now from the last you can say z is equal to minus 1. So we are getting third equation itself a value of z. Now we can substitute the value of z in equation number to get y. So y is equal to 3 by 5 times z plus 23 by 5. So 3 by 5, z value is minus 1 plus 23 by 5. Final is 5 minus 3, 24, 4. So y is equal to 4. Next, by using the value of y and z in first equation, we'll get the value of x. So x plus 3 times y value is 4 minus of 1 is equal to 15. So x minus plus 7, this is 12 and this is 1, so becomes 13 is equal to 15. So x is equal to 2. So value of x and y, z here unique, so we'll get a unique solution. X is equal to 2, y is equal to 4 and z is equal to minus 4. Thank you. Now sometimes we try to reduce the given matrix for a unique solution. We may obtain one of the following three cases. In this case, we say that there is no solution, or you can say the system is inconsistent. How? You can say this is non-zero, this is not zero, finally this element is also not zero. So in each of these form, we have an equation in which the LHS is 0. LHS is 0. You can see LHS are 0 and RHS is not 0. Here also LHS is 0, RHS is not 0. Here LHS is 0 and RHS is not 0. So in such a cases, the given system of linear equation is said to be inconsistent, or you can say there is no solution. We'll see same by using example. Consider the linear system of equation x plus 2y plus z is equal to 3, 2x minus y plus z is equal to 8, 3x minus 4y plus z is equal to 18. So first we'll write the given system of equation as augmented matrix. So write down the coefficient of first row. So 1, 2, this is 1, draw a line, constant, that is constant RHS constant. This is 2, this is minus 1, this is 1, this is 8, this is 3, minus 4 and 1, this is 18. This is my augmented matrix. This is my augmented matrix. Now our aim to make this one 1, but already it is 1, so no need to do anything. So we need to using this 1 will make this 0 and this 3 is the 0. How? So we need to change R2. How? R2 minus 2 time R1, and the second R3 we need to change how R3 minus 3 time R1. Yes, we can make two rows simultaneously as a 0, or we can perform two operation and then we'll write the reduced form, or you can say the equivalent augmented matrix next step. So it is time consuming to write each and every row operation and then matrix. So to reduce the time we need to do the number of possible row operation that we can perform. So for the first operation we'll write the first that row of second element of second row to minus 1 1 and 8, then after multiplying with 1 we'll get minus 2 minus 4 minus 2 minus 6. This is rough work, no, not related with the solution part, but it is help. So this is 0, this is minus 5 minus 1 and this is 2. Now by using this we can just say 3 minus 4 1 18, and then by multiplying we'll get the same element 2. So 3 times we need to multiply, so this is 3 minus 6 minus 3 and then minus 9 we need to add. So this one is 0, this one is minus 10, this is minus 2, this is 9. Now we'll write this element 1 2 1 3. Now this is the second row, so we'll write 0 minus 5 minus 1 2, this is 0 minus 10, this is minus 2, this is 9. We draw a line to make a difference between matrix and augmented matrix. Now we need to make this one as a 1. So simplest way, we need to change R2 by multiplying 1 by minus 1 by 5 to R2. So this is 1, this is 2, this is 1, this is 3, this is 0, this is 1, this is 1 by 5, this is 2 by 5. This one is a 0 minus 10 minus 2 and 9. So to write the augmented matrix. Now using this one we need to make this one as a 0. That is, we need to change R3 by R3 minus 2 time R2. So 1 2 1 3, no change in the first row, no change in the second row even, that 2 by 5, only the third row going to change. So first we'll write the element of third row 0 minus 10 minus 2 and then 9, then after that multiplication, so 0 0 0 0, this one is 10, so minus 10, so this is also 10, this one is 2, this is minus 4 plus, so this is 0, this is 0, this is again 0, this is 5. So our third row reduced to 0 0 0 and 5. Now from the third row we can see that LHS are 0 and RHS is a number. That is, you are getting the system like this: 0 times x plus 0 times y plus 0 times z is equal to 5. Finally you are getting 0 is equal to 5, which is not possible, or you can say absurd. So here there is no solution. So we can write the system has no solution or system is inconsistent. Thank you. Hello. In previous video we saw that how the system is inconsistent or that is there is no solution. In this video see the condition or form of matrix from augmented matrix from that we conclude that the system has infinitely many solutions. So when you aim to reduce the given matrix in a unique form, that is augmented matrix in for solution for solving a unique solution, you may see the following these three types. First one, so you can see the third row, all elements are 0. Here all 0. Here 3 and second both are 0. So if you see such a system, so in this case the system has infinite many solutions. So to express the solution in terms of parameter, so we'll write the solution in terms of parameter. Some people say take S, some people take T, some people take lambda. So choice is yours. You can write your answer in terms of arbitrary constant, which is called as a parameter. That is, the solutions is now totally depend on the value of parameter that you are assigning. So if for different value of parameter you are getting different solution. Hence the given system has infinite solution. We can consider an example. Consider the system of linear equation 2x minus y plus z is equal to 5, x plus y minus z is equal to 2, 3x minus 3y plus 3z is equal to 8. Now we can write the augmented matrix of given system. So this is 2, this is minus 1, 1, 5, 1, 1, minus 1, 2, 3, minus 3, 3, 8. We draw the line to differentiate between the matrix and augmented matrix. Now our aim to make this one 0, 0. So while making this one as a 0, 0, our first step to make the first row as a 1. It is very convenient way of doing row operation. So we are interchanging R1 and R2. So first we interchange R1 and R2. So this is 1, 1, minus 1, 2. This is 2, minus 1, 1, 5. This is 3, minus 3, 3 and 8. Now we need to make this one 0, this one 0. So we are changing R2. How? R2 minus 2 times R1. So we'll write here the element which is now going to change. So 1, 1, minus 1, 2, 3, minus 3, 3 and 8. Write down second row element here to perform the calculation. 2 minus 1, 1 and 5, and then multiply the first row element by minus 2. So minus 2, minus 2, 2 and minus 4. So this one is 0, this one is minus 3, this one is 3, and this one is 1. So we'll write this element over here, 0, minus 3, 3, and 1. Next, we'll use this first row to make this third row element as 0. So that is we want to change R3 by R3 minus 3 times R1. So we'll write the element which are not going to change. 1, 1, minus 3, 2, 0, minus 3, 3, 1, and then this one. So element of R3 is 3, minus 3, 3, and 8. If you multiply this R1 by 3, so this is minus 3, this is minus 3, this is 3, this is minus 6. If we add, we'll get this one is 0, this one is minus 6, this one is a 6, and this one is a 2. So our element is 0, minus 6, 6, and 2. Now, we can see either you can make this one as a 1, or you can say if we multiply this R2 by 2 and we add with R3, we'll get this element 0. So I don't think that doing more steps are required here. So we perform here R3, we want to change R3 plus 2 times minus 2 times R2. So we'll write the element of a row which are not going to change. So we'll write 1, 1, minus 1, 2, 0, minus 3, 3, 1. So this is the row of third element that we are going to change. So we write here for, and our operation is R3 minus 2 R2. So 0, minus minus plus 6, minus plus minus 6, and this is minus 2. If we add, we'll get this one 0, this one 0, this one, I think there is a mistake. So this is minus, this is 0. So every element of third row converted to 0. So from this third row, we say that since all the elements in the third row are 0, so we are getting infinitely many solutions. So we are getting infinitely many solutions. Sometimes it is asked to represent the solution by taking some variable. So if we let z is equal to say t in the, so from the second row we'll see y minus t is equal to minus 1 by 3, or 3, same, it is same as 3, that is minus 3 y minus plus 3 t is equal to minus 1, but, or you can say 1, and if you take common and divide, it becomes the same thing. So not to worry. So y is equal to t plus minus 1 by 3. And if we substitute the value of t and value of y and value of z in first row, you will get 2 times x minus t minus 1 by 3 plus t, here minus, sorry, let minus, yes, minus t is equal to 2. And if we solve, we'll get the answer as x is equal to minus 1 by 3. Now since t is any arbitrary number, so as you are changing the value of t, you are getting the different values of x, y and z. So therefore there are infinitely many solutions. Thank you for watching.